Hello there, and welcome to the Sleepy Science Channel. Tonight, we're stepping into the hidden world of crows. At first glance, they may seem familiar, perched on rooftops, crossing streets, or calling from the branches above us. But behind those dark eyes is a mind that has forced scientists to rethink what intelligence can look like. Crows remember faces, they solve problems, and they pass warnings through families and neighborhoods. They can plan, deceive, cooperate, and learn from one another in ways that feel startlingly similar to humans. Their world is not random noise and flapping wings. It is a complex web of memory, danger, opportunity, and trust. Crows can often be found watching people for hours, learning, strategizing, and planning their next move. A bird you pass on an ordinary morning may already know more about you than you would care to believe. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, there's nothing you need to do but relax. Let your shoulders soften. Allow your breathing to slow. And as the day begins to gently fade away, join me as we explore these fascinating creatures together. Let's begin. Crows can recognize individual human faces for years. In one famous study, researchers wore masks while trapping and banding wild crows. The birds quickly learned which face meant trouble, and the memory did not fade when the moment passed. Years later, crows still scolded the dangerous mask, even when it was worn by different people and paired with neutral clothing. More astonishingly, birds that had never been captured joined the alarm. This suggested that the warning had spread socially, from crow to crow, through watching, listening, and reacting together. For an animal living among humans, this ability is powerful. A city is full of faces, and most pass without meaning. But a crow can sort the harmless walker from the person linked to danger, then store that information for later. It turns an ordinary street into a map of memory, where every human encounter may become part of a hidden record. Some crows use tools with astonishing patience and precision. Tool use was once treated as a signature of human cleverness, then as a rare skill shared with apes. Crows changed that picture. In experiments and in the wild, certain species use sticks, stems, leaves, and other objects to reach food that their beaks cannot touch directly. What makes this so remarkable is not just the tool itself, but the controlled sequence behind it. A crow may inspect a crevice, choose an object of the right length, adjust its grip, and probe again after a failed attempt. It is not a simple reflex. It looks like focused problem solving, with attention moving between goal, object, and result. In some tests, crows have even selected tools before the reward is visible, as though holding the purpose in mind. Watching this unfold can feel strangely familiar. A bird pauses, evaluates, tries again, and suddenly the impossible becomes reachable. Crows can warn their families about dangerous people. A crow's alarm is not just a burst of panic. It can become a message that reshapes the behavior of everyone nearby. When one bird spots a person associated with danger, its calls may draw relatives and neighbors into the air. They gather, circle, scold, and sometimes follow the person at a distance. To us, it may sound like chaos. To the crows, it can function like a public announcement. Young birds learn where to look, whom to fear, and how urgently to react. This turns personal experience into shared protection. A single unpleasant encounter does not remain locked inside one mind. It can ripple outward through a family group, then linger in the habits of birds that were never directly threatened. In a world filled with cars, pets, traps, and unpredictable humans, that social warning system is a form of survival intelligence written in sound. A crow's brain solves problems without looking like ours. The surprising thing about crow intelligence is that it evolved on a very different path from human intelligence. Mammal brains have a layered cerebral cortex, which is often linked with complex thinking. Birds do not have that same structure. For a long time, this led people to underestimate them. But modern neuroscience has shown that bird brains can pack many neurons into compact spaces, especially in regions involved in flexible behavior and decision-making. In other words, nature found another design for cleverness. A crow does not need a human-like brain to remember, plan, judge, and learn. Its mental machinery is arranged differently, yet it can still produce results that feel startlingly sophisticated. This makes crows important far beyond bird study. They show us that intelligence is not one narrow invention. It can arise in separate branches of life, shaped by different bodies, different pressures, and different worlds. Crows remember kindness, and they may repay it later. People who feed local crows often report a strange development. The birds begin to appear at regular times, wait from familiar rooftops, and sometimes leave small objects behind. These so-called gifts can include bottle caps, bits of glass, stones, or shiny fragments. Scientists are cautious about calling it gratitude, because a crow's motives are hard to prove. Still, the behavior hints at something more interesting than simple hunger. Crows can learn which people provide safe food, and they can treat those people differently over time. A repeated act becomes a relationship, at least from the bird's practical point of view. That does not mean every object is a deliberate present. Some may be accidents, and some may come from curious handling. Yet the pattern still changes how the world feels. The crow on the fence is not just reacting to crumbs. It may be recognizing a particular human history. New Caledonian crows can craft hooks from twigs. On the islands of New Caledonia, one crow species has become famous for a skill that seems almost impossible at first glance. These birds do not merely pick up ready-made tools. They can manufacture them. A crow may snap a twig from vegetation, strip away leaves, shape the end, and turn it into a hooked probe. That hook can then pull insects or grubs from narrow hiding places inside wood. The hook matters because it catches prey more effectively than a straight stick. This is not random fiddling. It is a repeated technique, learned and refined by birds in a particular environment. Some even show preferences for certain plant materials, as though recognizing which stems make better equipment. The scene is remarkable because it compresses so much thought into such a small action. A bird looks at a branch and, in effect, sees a tool waiting inside it. Crows hold noisy gatherings around their dead. When crows discover a dead crow, they may gather in tense calling groups. These events can look almost like funerals, which is why they fascinate people so much. But the science points toward a practical mystery. A dead body can signal danger. There may be a predator nearby, a poisoned food source, a hazardous road, or some other threat worth learning about. By assembling around the body, crows appear to gather information. They look, call, and may become wary of the surrounding area afterward. The behavior is powerful because it shows how death becomes data. A single loss can teach the living where risk has entered the landscape. It also reveals how strongly crows attend to their own kind. They do not simply ignore a fallen bird and move on. They investigate. They react together. They turn a grim discovery into a lesson that may help others survive. Young crows learn family secrets before living independently. Many young birds leave the nest and quickly face the world alone. Crows often take a slower path. In several species, juveniles remain close to their parents after fledging, watching how adults feed, respond to threats, and move through familiar territory. This extended learning period matters because a crow's life is full of local knowledge. Which yard has a dangerous dog? Which tree hides good insects? Which human throws food? Which hawk patrols the field edge? None of this can be fully inherited. It has to be learned in place. Young crows trail their family groups like apprentices, absorbing the rules of a neighborhood that outsiders might miss completely. Their noisy begging and awkward movements may look simple, but behind them is a long education. A young crow is not just growing feathers and strength. It is gradually inheriting a map of survival from birds that know the area well. Crows can plan for rewards they will need later. Planning means acting now for a future that is not immediately present. That is a demanding mental skill, and crows have shown signs of it in carefully designed experiments. In some tests, birds were offered a choice between an instant food reward and an object that could unlock a better reward later. Many chose the useful object, even though it had no value in the moment. This suggests they could hold a future situation in mind and prepare for it. The result is striking because it moves beyond simple trial and error. The bird is not only reacting to what is in front of it, it is treating time as part of the problem. In the wild, that capacity would be valuable. Food may need to be saved, tools may need to be selected, and danger may require waiting. For a crow, tomorrow is not entirely invisible. A crow's world is built on memory, strategy, and trust. To understand a crow, imagine a life where nearly every choice depends on remembering what happened before. Food appears and disappears. Rivals watch from branches. Family members call from nearby rooftops. Humans behave differently from one street to the next. In that world, intelligence is not a luxury. It is the basic structure of survival. A crow must know when to approach, when to wait, when to call, and when to hide what it has found. Trust also matters because crows live in social networks. Some companions are reliable. Others may steal. A parent, mate, sibling, or neighbor can change the outcome of a risky moment. This makes their daily life feel more like a shifting game than a simple search for food. The hidden wonder is that it unfolds all around us. A parking lot, a garden, or a school roof may be part of a crow's private strategy. Ravens and crows belong to one remarkably intelligent bird family. Crows, ravens, rooks, jackdaws, magpies, and jays all belong to the corvid family. This group has produced some of the most mentally flexible birds ever studied. Their success is not based on one trick. It comes from curiosity, strong memory, social awareness, and the ability to solve new problems when old routines fail. Ravens may test objects with playful persistence. Jays can remember hidden food locations. Magpies have passed mirror tests under certain conditions. Crows, meanwhile, thrive in wild places and busy cities alike. The family resemblance is not always obvious at first glance because a glossy raven and a blue jay look so different, yet their minds share a theme. They are active investigators of the world. Corvids remind us that intelligence did not blossom in only one branch of life. It grew feathers, took flight, and learned to watch us from wires, trees, and rooftops. Crows can drop nuts into traffic to crack them open. In some cities, crows have learned to turn roads into food processing machines. A hard nut can be difficult to open with a beak alone, but a passing car brings weight, force, and perfect timing. The bird drops the nut onto the road, waits for a vehicle to crush the shell, then returns to collect the edible prize. In the most fascinating reports, crows appear to place nups where traffic is likely to pass, and some use pedestrian crossings to retrieve food more safely after cars stop. The behavior is not magic. It is learning, shaped by opportunity. A city introduces dangers, but it also provides tools that no forest ever offered. The crow does not understand traffic as an engineer would. It does not need to. It learns patterns, consequences, and timing well enough to exploit a human system. For a bird, that is an astonishing urban adaptation. American crows often stay with their parents for years. In many American crow families, young birds do not vanish into independence as soon as they can fly. They may remain in their parents' territory for several years, especially when conditions favor cooperation. This creates a family structure that can feel surprisingly complex. Older offspring help watch for danger, defend territory, and sometimes assist with raising younger siblings. For the parents, having experienced helpers nearby can improve the odds for the next brood. For the young adults, staying home can offer food access, protection, and valuable experience before attempting to breed on their own. This changes the way we should see a group of crows in a field or neighborhood. They may not be a random crowd. They may be a family with history, roles, and relationships stretching across breeding seasons. The young crow calling from a branch may be living in a household that has endured longer than some human friendships. Some crow families raise chicks with older siblings helping. A crow nest can be the center of an entire family effort. While the breeding pair remains essential, older offspring may help bring food, guard the area, and alert the adults to danger. This cooperative breeding is especially valuable because crow chicks are demanding. They hatch helpless, hungry, and dependent on constant care. Every extra set of eyes and wings can matter. An older sibling that helps feed nestlings is also gaining practice. It learns how to handle food, read chick behavior, and respond to threats near the nest. In time, those skills may help when it raises its own young. The arrangement shows that crow society is not built only on competition. Cooperation can be a practical strategy, shaped by kinship and local conditions. A family group calling around a nest may sound loud and disorderly, but beneath the noise is a coordinated effort to bring a new generation safely into the air. Crows may follow wolves to steal scraps from kills. In northern landscapes, ravens are especially famous for shadowing wolves, and crows may also take advantage of predators when the opportunity appears. A large carnivore can do what a crow cannot. It can bring down an animal and open a carcass with teeth strong enough to tear hide. For scavenging birds, that event creates a temporary feast. The risk is obvious because a predator is dangerous at close range. Yet the reward can be worth careful watching. Birds may gather near a kill, wait for a safe opening, then dart in to grab pieces left behind. This relationship reveals an important truth about crow survival. Intelligence is not always about inventing tools or solving laboratory puzzles. Sometimes it means reading another animal's behavior and exploiting the aftermath. A crow that understands where predators travel may gain access to food hidden behind strength it does not possess. Urban crows have learned the rhythm of traffic lights. City life is full of patterns, and crows are excellent pattern readers. Traffic lights create predictable pauses in a dangerous flow of machines. Some urban crows appear to take advantage of those pauses when feeding on roads, retrieving dropped food, or investigating objects that would be too risky while vehicles are moving. The key is not that a crow understands traffic law. It understands repetition. Cars stop here. People cross there. A chance opens, then closes. That kind of timing can turn a hazardous street into a usable landscape. It also shows how quickly wildlife can adapt when human environments become part of daily life. What looks to us like noise and movement may look to a crow like a schedule. The red light, the crowd waiting, the engine slowing, and the brief gap that follows can all become clues. In the city, survival may belong to the best observer. A crow can hide food while pretending not to. Food caching is not just storage. For crows, it can become a performance. When a bird has something valuable, it may act as though nothing important is happening. It might walk away casually, probe the ground without depositing anything, or create a false impression before choosing a real hiding place elsewhere. This behavior becomes especially meaningful when other birds are nearby. A hidden item is only useful if it remains hidden. If a rival sees the exact location, the cache may be gone before the owner returns. So the crow manages attention. It treats watchers as part of the problem. That is what makes the behavior so compelling. The bird is not merely burying food. It is responding to what another creature might know. Such moments give us a glimpse of a social mind at work, where survival depends not only on finding resources, but also on controlling information. Other crows may watch a hiding place and steal later. A crow that hides food is not always alone, even when it seems to be. Another bird may sit nearby, looking casual, while carefully noting where the item disappears. It does not have to strike immediately. The thief can wait until the owner leaves, then return to the exact spot and take the prize. This kind of delayed theft creates an invisible contest between memory and secrecy. The watcher must remember the location. The hider must judge whether it was observed. In species that cache food, these pressures can become intense. Every hidden meal is a gamble. Every nearby bird is a possible witness. The most fascinating part is how ordinary the scene can look. Two dark birds on a lawn may seem unremarkable, but one may be storing a future meal, while the other is recording the place in silence. Beneath the calm surface, a small drama of attention is unfolding. Crows remember who cheated them in food experiments. Researchers have tested crow memory by creating simple exchanges with human partners. In some versions, a person behaves fairly and gives the bird the expected food reward. Another person takes the food or fails to complete the exchange. Later, the crow can show a clear preference for the reliable partner. This is remarkable because it suggests the bird is not only reacting to food in the moment, it is keeping track of individual behavior across time. A face, a choice, and an outcome become linked in memory. That skill would be useful in the wild, where social life is full of changing partners and rivals. Some individuals are worth approaching, others are not. The experiment feels almost like a tiny moral drama, although the crow is probably thinking in practical terms rather than human ones. Fairness, from its point of view, may mean knowing who can be trusted when food is on the line. Crows can distinguish between threatening and harmless human behavior. Not every person near a crow matters in the same way. A jogger passing by, a gardener working below, and a person staring directly at a nest can signal very different levels of risk. Crows are good at noticing those differences. They may react strongly to someone who approaches them, aims attention at them, or behaves in a way linked to past danger, while ignoring people who keep moving without interest. This ability helps them live close to us without wasting energy on constant alarm. In cities and suburbs, humans are everywhere. Treating every person as a threat would be exhausting and inefficient. Instead, crows sort us by behavior, context, and memory. That makes their coexistence with people more sophisticated than simple fear. A crow on a lamppost may be evaluating posture, direction, distance, and history. It is not just seeing a human. It is judging what kind of human moment this might be. Some crows understand water displacement well enough to solve puzzles. In a famous style of experiment inspired by an ancient fable, a bird is faced with floating food trapped inside a tube of water. The reward is visible, but just out of reach. The solution is not to peck harder or give up. The bird must drop solid objects into the tube, so the water rises and brings the food closer. Some crows and their close relatives have managed this with impressive judgment. They often choose sinking objects over floating ones, and larger objects when those raise the water faster. That means they are not only repeating a trick, they are responding to the physical properties of the situation. The scene feels simple until you imagine what the bird must notice. Water level, object weight, distance to the food, and the result of each action all become part of the same problem. It is a tiny lesson in physics, solved with a beak. Crows can choose the right tool before seeing the reward. One of the most astonishing things about crow intelligence is how well it can reach beyond the present moment. In some experiments, a bird is shown a device that can only be opened later with a particular object. The reward is not immediately available, and the useful object may be mixed with tempting but useless alternatives. A successful crow selects the tool it will need, keeps it, and uses it when the opportunity appears. That is not the same as grabbing food that is already there. It means the bird can connect a future problem with a current choice. The object becomes valuable because of what it will do later. This ability makes perfect sense for an animal that hides food, searches complex environments, and competes with observant rivals. It also changes the way we see a crow holding a stick. It may be carrying a plan, not just a piece of wood. A crow's call can carry different meanings to nearby listeners. To human ears, many crow calls sound like rough cries repeating from a tree or rooftop. But to other crows, those sounds can carry useful information. The pace, intensity, pitch, and social setting of a call can change what nearby birds do next. A sharp burst may draw attention to danger. A softer exchange may help family members keep contact as they move through cover. Longer calling can pull other birds toward a food source or a disturbance. The meaning is not contained in the sound alone. It also depends on who is calling, where it happens, and what the listeners already know. This is why crow communication feels so layered. It is not a human language, yet it is far from random noise. Each call is part of a living situation. A crow hears not just a sound, but a clue about what may be unfolding beyond its own view. Crow families use alarm calls to recruit reinforcements. When danger appears, one crow rarely has to face it alone. A sudden alarm can bring relatives and neighbors from nearby trees, roofs, or fields. The arriving birds may join the calling, circle above the threat, or take turns making close passes. This behavior is often called mobbing, and it can be surprisingly effective. A perched owl, a prowling cat, or a hawk near a nest becomes harder to ignore when several crows are shouting its location to the whole area. The goal is not usually to defeat the threat directly. It is to expose it, pressure it, and make the place uncomfortable enough that it leaves. The call turns private fear into group action. It also teaches younger birds what deserves alarm. One crow notices danger, and within moments the landscape itself seems to wake up. The warning spreads through wings, voices, and shared attention. Crows mob owls because owls can hunt them at night. An owl resting in daylight might seem harmless, but crows treat it as a serious problem. The reason is rooted in the different hours of their lives. Crows are active by day and vulnerable after dark, when many owls become skilled hunters. If crows discover an owl roosting nearby, they often gather and harass it with loud calls and repeated swoops. This daylight mobbing is a way to remove a nighttime threat before darkness gives it the advantage. It also helps the group learn where the predator is hiding. The owl may remain still at first, relying on camouflage, but the noise can draw more birds until secrecy fails. What looks like bullying is actually risk management. Crows are using the safety of daylight to confront a creature that would be far more dangerous later. In that moment, the forest becomes a court of alarm, and the owl is exposed. Crows sometimes chase hawks in organized neighborhood groups. A hawk crossing open sky may suddenly find itself escorted by furious crows. The birds rise from separate perches and converge behind it, calling as they fly. They may not be related, and they may not all have nests nearby, yet the shared danger pulls them into action. Hawks can take eggs, chicks, or adult birds, so allowing one to pass unnoticed is risky. By chasing it, the crows make hunting more difficult and announce its presence to the surrounding area. Their movements can look chaotic, but the effect is coordinated. One bird distracts. Another follows. Others join from a distance. The hawk is forced to spend energy avoiding harassment instead of scanning for prey. This group response shows how crow society can stretch beyond the family. In a neighborhood of watchful birds, a predator's arrival becomes everyone's business, and the sky itself turns against it. A single crow may know dozens of local danger spots. A crow's home range is not just a stretch of land. It is a remembered landscape of chances and risks. One alley may hold spilled food every morning. Another may lead to a yard with a restless dog. A certain tree might shelter a nesting hawk. A road crossing may be safer after traffic slows at predictable times. Over months and years, a crow can build an internal map filled with these details. That knowledge is not abstract. It guides where the bird lands, when it calls, which route it takes, and how close it dares to approach. This is why experienced urban crows can seem almost streetwise. They do not survive by being fearless. They survive by knowing the difference between one place and another. To us, the neighborhood may look ordinary. To a crow, it may be layered with invisible warnings, remembered meals, and old decisions that still matter. Crow roosts can gather thousands of birds in winter. As daylight fades in the colder months, crows may stream across the sky toward communal roosts. A few birds become dozens, then hundreds, and in some places the gathering grows into thousands. They settle in trees, on buildings, or near warm urban spaces where predators may be easier to spot. The sight can feel almost unreal, as though the evening has learned to move in one direction. These roosts are not random piles of birds. They are seasonal meeting grounds shaped by temperature, safety, and food. A single crow sleeping alone is vulnerable, but many eyes and ears make danger harder to hide. The group also benefits from shared movement. Birds leaving the roost in the morning may follow successful foragers toward feeding areas. What begins as a night shelter can become a living information center. In winter, the sky over a city may briefly reveal the hidden scale of crow society. Large roosts help crows exchange information about food. A winter roost can work like an evening meeting place. Birds arrive from different parts of the landscape after spending the day searching for meals. Some have found reliable food near farms, markets, shorelines, or waste sites. Others have had little success. When they gather, they do not sit in silence. They call, shift positions, watch one another, and later leave in directions that may reflect what they have learned. Researchers have long suspected that communal roosting can help birds discover productive feeding areas by following others the next morning. This does not require a crow to explain anything in a human sense. It only has to pay attention to who looks well-fed, who leaves confidently, and where groups begin to move at dawn. The roost becomes more than shelter. It becomes a social compass. In the cold season, information can be as valuable as food itself, and crows gather both. Crows often sleep near city lights for safety. Many crows choose nighttime roosts in urban places, even when trees and open countryside are nearby. City centers may seem strange places for wild birds to sleep, but they offer advantages. Streetlights reduce the cover of darkness for some predators. Buildings can block harsh wind. Human activity may discourage certain hunters. Warm surfaces and sheltered spaces can also make winter nights slightly easier to endure. A crow roosting above a busy street is not choosing noise for its own sake. It is balancing danger against opportunity. The city changes the rules of night. Lights reveal movement. Traffic creates disturbance. Tall structures provide vantage points. For a bird that depends on seeing threats early, those details matter. This is one reason crows can feel so strongly woven into human neighborhoods. While we sleep behind windows, they may be above us, using our artificial landscape as a protective arrangement of light and height. Some crows wash food before eating it. Crows are often seen carrying food to puddles, bird baths, streams, or shallow pools, then dipping it repeatedly before eating. The behavior can have several explanations. Dry bread may soften in water. Sticky food may become easier to handle. Dirt or grit may be removed from a morsel found on the ground. In other cases, the action may be exploratory rather than hygienic. Crows investigate objects with their beaks, and water can change texture, smell, and taste. What makes the behavior interesting is how adaptable it is. The bird is not tied to one rigid feeding method. It can modify food before swallowing it, using an available feature of the environment to improve the meal. The scene may look almost domestic, as if the crow is washing up before dinner. In truth, it reveals flexible foraging. A paddle becomes a tool, and a scrap becomes more useful after a small transformation. Carrion crows can live successfully beside farms and cities. The carrion crow has become one of Europe's most adaptable birds. It can forage in open fields, woodland edges, coastal areas, villages, and busy urban spaces. Its name points to one part of its diet, but this bird is not limited to dead animals. It can eat insects, grain, eggs, fruit, refuse, and almost anything else that opportunity provides. That flexibility is a major reason it thrives beside people. Farms expose soil and attract insects. Towns create discarded food. Roads produce carcasses. Parks offer nesting trees and open lawns. The crow reads each setting for possibilities, then shifts behavior as conditions change. This adaptability can bring it into conflict with humans, especially where it raids nests or crops. Yet it also shows why crows are such powerful survivors. They do not need a perfect wilderness. They can make a living in the mixed, altered landscapes that now cover so much of the world. Hooded crows and carrion crows form a strange hybrid zone. Across parts of Europe, two closely related crows meet like neighboring versions of the same idea. The carrion crow is mostly black. The hooded crow has a grey body with black wings, head and tail. Where their ranges overlap, they can interbreed, producing birds with mixed plumage. This contact zone has fascinated scientists because the birds remain distinct across broad regions despite being able to mate. It raises a deep evolutionary question. How different must two groups become before they count as separate species in practice, not just in appearance? The answer is not always clean. Behavior, mate preference, geography, and genetics all play a part. A field in the hybrid zone can contain living evidence of evolution in motion. One bird may look black, another grey, and another somewhere between. Their feathers become a map of ancestry, choice, and the slow sorting of life across a continent. Crows are found on every continent except Antarctica and South America. Crows are remarkably widespread, but their absence from two continents is just as interesting as their presence on the others. They have colonized North America, Europe, Asia, Africa, and Australia, adapting to forests, coasts, grasslands, mountains, farms, and cities. Yet Antarctica offers almost none of what they need. It has extreme cold, limited nesting habitat, and scarce year-round food for a land bird of this kind. South America is different. It has many intelligent birds and rich ecosystems, but true crows never became established there in the same way. Biogeography often depends on ancient roots, barriers, and accidents of evolution. A bird family can be brilliant and flexible, yet still shaped by where ancestors happened to spread. This gives the crow story a global pattern with missing pieces. Their success is enormous, but it is not universal. Even one of the world's most adaptable birds has limits written into geography. The Hawaiian crow once helped forests spread their seeds. The Hawaiian crow, known as the Alala, lived in native forests where it played a role that was larger than its body suggested. It ate fruits from local plants and passed seeds through its digestive system, helping move them away from parent trees. For certain native species, this kind of seed dispersal matters deeply. A seed that falls directly beneath its parent may face shade, competition, or hungry insects. A bird can carry it into new ground, wrapped in a small parcel of fertilizer after digestion. In island ecosystems, these relationships can become especially important because there may be fewer animals available to perform the same task. The Alala was not just a clever crow. It was part of the forest's reproductive machinery. When such a bird disappears, trees may lose a partner that helped them spread through the landscape. The fate of one species can quietly reshape the future of many plants. The Hawaiian crow is now extinct in the wild. The Alala has one of the most haunting stories in the crow family. Once found in Hawaiian forests, it was driven out of the wild by habitat loss, disease, introduced predators, and other pressures that strike island birds especially hard. Today, the species survives through human care and conservation breeding, with reintroduction efforts facing serious challenges. Its situation is a reminder that intelligence does not make an animal invincible. A crow can remember faces, use tools, and solve problems, yet still be overwhelmed when its entire world changes too quickly. Islands often hold species that evolved without certain predators or diseases, which leaves them vulnerable when new threats arrive. The Alala also carries cultural importance in Hawaii, so its loss is not only ecological. It is a break in a living relationship between people, forest, and bird. Its continued survival now depends on whether protection can rebuild a place for it to belong. Crows sometimes cache food in hundreds of different places. A crow that finds more food than it can eat may not waste the surplus. It hides portions in separate locations, tucking them under leaves, grass, soil, snow, bark, or small debris. Spreading the food across many caches reduces the risk of losing everything at once. If another animal finds one hiding place, others may remain safe. This method demands a powerful memory for location and context. A crow has to remember not only where it buried food, but what kind of food it stored and whether it is worth returning soon. Perishable items may need quick retrieval. Harder foods can last longer. The strategy turns the landscape into a pantry scattered across space. To a person walking by, a patch of ground is just ground. To the crow, it may contain a private inventory of future meals. Each hidden piece is a bet placed against hunger, weather, and competition. A crow can recover hidden food weeks after burying it. Returning to a cache after a long delay is not as easy as it sounds. The world changes. Leaves shift, snow falls, grass grows, and other animals disturb the ground. Yet crows and their relatives can relocate stored food with impressive accuracy. They rely on landmarks, spatial memory, and perhaps the relationship between objects around the cache. A rock, a fence post, a root, or the angle of a path may help guide them back. This ability is not a party trick. It is survival during seasons when food becomes unpredictable. The bird that remembers well can turn yesterday's abundance into tomorrow's meal. Memory also has to be selective. A crow must avoid wasting energy checking empty or spoiled sites. Its mind becomes a living map of hidden resources, constantly updated by experience. When a crow lands and digs in what looks like an ordinary patch of earth, it may be opening a memory. Some crows move caches when they suspect they were watched. A hidden meal is only safe if the hiding stays secret. When a crow notices that another bird has seen where food was stored, it may return later, dig up the item, and hide it somewhere else. This behavior is fascinating because it suggests sensitivity to another animal's viewpoint. The crow is not merely responding to theft after it happens. It is reducing the chance of theft before it occurs. In some studies of corvids, birds with experience stealing from others are especially likely to protect their own caches. That detail is striking. A bird that knows how to be a thief may better imagine what a thief will do. In the wild, this creates a constant contest of watching and being watched. The ground may hold buried food, but the real battle is over knowledge. For a crow, secrecy can be as important as strength, speed, or hunger. Crows may use playful behavior to practice real survival skills. Play can look pointless from the outside. A crow drops an object, chases it, wrestles with a stick, or tugs at another bird for no clear reward. Yet play may help young animals build the skills they will later need. A tumbling game can sharpen balance. Object play can teach texture, weight, and breakability. Social play can help a bird learn how hard to push before a companion pushes back. Crows live in a world where flexibility matters, so practice without immediate pressure may be valuable. Play also reveals a mind with room for curiosity. The bird is not locked into feeding and fleeing. It explores what objects can do and how others respond. That makes play one of the most engaging windows into crow life. It reminds us that survival is not always stern. Sometimes a future expert begins as a young bird bothering a leaf simply because it can. Young crows have been seen sliding down snowy roofs. There are reports and videos of crows sliding down sloped snowy surfaces, then returning to do it again. The behavior has captured attention because it looks so unmistakably playful. A bird crouches, glides, reaches the bottom, and repeats the action when no obvious food or escape is involved. Scientists are careful when interpreting animal play because human viewers can easily project emotions onto wildlife. Still, repeated sliding in safe conditions fits what researchers often consider play behavior. It is voluntary, flexible, and apparently rewarding in itself. For a young crow, sliding might also help develop balance and body control. Snow creates a surface unlike branches, soil, or air, and the bird learns through movement. The scene is delightful because it disrupts the old idea of crows as only grim scavengers. Here is a dark bird on a white roof, turning winter weather into an experience worth repeating. Crows sometimes play with objects that offer no obvious reward. A crow may pick up a twig, a plastic cap, a pebble, or a piece of bark and handle it with intense interest. It may turn the object over, carry it away, drop it, retrieve it, or offer it briefly to another bird. Sometimes there is no food inside, no nest to build, and no immediate purpose anyone can see. This kind of object play matters because it gives the bird a way to learn the world's properties before survival depends on them. Hard things crack differently from soft things. Hollow items sound different when struck. Light objects blow away. Flexible objects bend. Such knowledge may later help with tool use, food handling, or problem solving. Curiosity becomes a training ground. A crow does not need to know the future value of every object it explores. By investigating widely, it builds a mental library of possibilities. Useless play can become useful knowledge later. A crow's curiosity can lead it toward remarkably inventive solutions. Curiosity is risky, but for crows, it can also be a doorway to opportunity. A cautious animal may avoid anything unfamiliar. A curious one may inspect it, test it, and discover a new source of food or shelter. Crows often approach novelty with a mixture of suspicion and interest. They may circle an object, peck lightly, retreat, and return. That slow investigation allows them to learn without being reckless. In changing environments, especially near humans, this trait can be powerful. A sealed container, a dropped wrapper, a garden sprinkler, or a new feeding setup may become useful only after exploration. Many clever behaviors probably begin this way, not as sudden genius, but as repeated testing by a bird willing to ask what happens if it tries. Curiosity turns the unknown into a series of small experiments. For a crow, the world is not merely endured. It is examined for hidden openings. Crows can learn by watching other crows succeed. A crow does not have to discover every solution alone. If another bird finds food, avoids danger, opens a tricky object, or reacts to a threat, observers can gain information without paying the full cost themselves. Social learning is especially useful in a species that lives around family groups and familiar neighbors. A young crow can watch an experienced adult probe a certain place for insects. A newcomer can notice where others gather after a field is plowed. A cautious bird can learn which human behavior causes alarm by watching the reactions of the group. This makes crow knowledge cumulative at a local scale. One bird's success can shape the choices of others. It also helps explain why different crow communities may develop different habits. The neighborhood becomes a classroom, and every successful forager is a possible teacher. In such a world, watching carefully can be almost as valuable as doing. Young crows study their parents before trying difficult tasks. A juvenile crow often enters the world as an observer before it becomes a skilled actor. It follows adults, begs for food, and watches how they handle the landscape. When a parent flips leaves, probes bark, opens a shell, or approaches a human feeding spot, the young bird can study the sequence before attempting it. This matters because many crow tasks require judgment. Too much boldness can be dangerous. Too little can mean missing a meal. Parents provide more than food during this period. They model decisions about timing, distance, and technique. The young bird gradually shifts from watching to practicing, making clumsy attempts that become smoother with experience. This kind of learning helps explain why crows can develop local traditions. A behavior does not need to be written entirely in instinct if it can be demonstrated by adults. Family life becomes a channel through which practical knowledge moves forward. Crows can recognize familiar voices from other members of their group. In a crow community, sound carries identity. Birds that live near one another hear each other day after day, and familiar calls can help them track companions without constant visual contact. A family member hidden behind leaves may be recognized by voice. A neighbor calling from a boundary may be treated differently from a stranger. This ability is useful because crow life often unfolds in cluttered habitats where birds move in and out of sight. Recognition by sound helps maintain relationships, coordinate movement, and respond appropriately to trouble. It also prevents wasted effort. Not every call deserves the same reaction. A trusted relative may need attention. An unfamiliar bird may signal intrusion. To us, the difference may be subtle or completely lost. To crows, it can matter. Their social world is partly acoustic, built from remembered voices that travel across yards, fields, and branches, keeping individuals connected even when the body is unseen. Different crow populations can develop slightly different call patterns. Crows are not identical everywhere they live. Local groups can differ in the rhythm, tone, and use of their calls. These differences are sometimes compared to dialects, although they are not dialects in the human sense. They emerge because birds learn from the sounds around them and adjust to their social environment. A crow growing up in one region may become tuned to the calls used by its neighbors, while another population develops slightly different habits. This can help birds recognize familiar groups or respond correctly to local signals. It also shows that crow communication is not fixed like a simple mechanical alarm. It has room for learning, variation, and cultural texture. The idea is quietly astonishing. A crow flying into a new area may not only encounter unfamiliar trees and food sources. It may enter a different soundscape, where the voices of its own kind carry local patterns shaped by generations of listening. Crows may sound harsh because their social lives are complicated. The rough caw of a crow can seem blunt, even unpleasant, when heard from a window in the early morning. But harshness does not mean simplicity. Crows need sounds that travel outdoors, cut through wind, and reach companions across busy habitats. Their calls must work in forests, fields, streets, and rooftops. They also need to signal urgency, identity, location, and mood in situations that change quickly. A smooth song might please human ears, but a sharp call can be more useful when a predator appears or a group must gather. The sound fits the life. Crows are negotiating territory, family bonds, food discoveries, rivalries, and danger in open air. Their voices carry the pressure of that social world. Once you listen with that in mind, the noise begins to feel different. It is not ugliness. It is information with edges, shaped for distance, speed, and survival. A crow's beak is a versatile tool for testing the world. A crow has no hands, yet it still investigates with remarkable skill. Its beak can pry, tug, tap, lift, tear, carry, and probe. The tip is sensitive enough to explore textures, while the structure is strong enough to open many kinds of food. A crow may use it to peel bark, flip leaves, pull at packaging, examine a shell, or test whether something is edible. The beak also works with the feet. A bird can pin an object down, angle its head, and apply force with surprising precision. This combination allows crows to interact with objects in ways that look almost hand-like at times. Their intelligence is therefore deeply connected to their anatomy. A clever mind still needs a way to act on the world. For crows, the beak is more than a mouth. It is an instrument of investigation, and every peck can be a question. Crows can open containers that many animals would ignore. A closed lid, a food wrapper, or a partly sealed box can be meaningless to many creatures. For a crow, it may be a challenge worth studying. These birds often investigate containers by pulling at edges, pecking seams, flipping objects over, and trying different angles until something gives way. This is especially useful near humans, where food is often hidden inside packaging rather than lying openly on the ground. The crow does not need to understand the container the way a person does. It only needs persistence and the ability to learn from small changes. A loose corner, a torn flap, or a rattling sound can guide the next attempt. The impressive part is the willingness to keep testing instead of abandoning the puzzle at once. Many animals are defeated by barriers that separate sight from access. Crows often treat the barrier itself as the next object to solve. Some crows bend wire into tools during laboratory tests. One of the most famous demonstrations of crow problem-solving involved a bird named Betty. In a laboratory task, food was placed inside a small bucket that sat beyond reach. A straight piece of wire lay nearby, along with a hooked one. When the hooked tool was taken away, Betty did something remarkable. She pressed the straight wire against a surface and shaped it into a hook, then used it to lift the bucket. The moment became famous because it looked less like training and more like invention. She had not simply selected an object that already worked. She altered the object so it could work. That difference matters. It shows that a crow can recognize a problem, understand the missing feature, and change material in response. In that small act, wire stopped being scrap. It became a purpose-built extension of the bird's mind. Crows understand that a hidden object has not vanished. For many young animals, what disappears from view may as well be gone. Crows show a stronger grip on the unseen. If food is placed behind a barrier or tucked under cover, they can continue searching as though they understand that it still exists somewhere out of sight. This ability is called object permanence, and it forms a basic foundation for more advanced thinking. Without it, hiding food would be nearly useless. A bird could not return to a buried meal, follow the movement of a rival's cache, or reason about what lies inside a closed space. The power of this idea is easy to miss because it feels obvious to us. But for a crow, it turns the world into something deeper than surfaces. A leaf pile can contain a meal. A box can conceal a reward. Absence is not emptiness. It is a question waiting to be solved. Crows can solve multi-step puzzles in the right order. Some crow experiments look almost like escape routes built for birds. A reward is visible, but reaching it requires several separate actions. The bird may need to pull a short stick from one place, use it to get a longer stick from another, then use that longer tool to reach the food. The impressive part is the sequence. If the steps are done out of order, nothing works. A successful crow has to hold the final goal in mind while completing actions that are not rewarding by themselves. That kind of chained problem-solving demands patience and flexible attention. It also resembles the challenges a crow faces outside the laboratory. Food may be locked inside bark, hidden beneath objects, or available only after another obstacle is moved. The bird must work through the situation rather than react once. Each solved step becomes a bridge toward the next. A crow may choose a future tool over immediate food. Imagine being offered a snack right now or an object that will help you get a better meal later. For many animals, the immediate reward wins. Some crows can resist that pull when the future payoff is clear enough. In experiments, they have selected a useful item and saved it for a later task, instead of taking a lesser reward at once. This is not about storing food in the ordinary sense. It is about valuing an object because of a coming situation. That suggests the bird can mentally step beyond the present and prepare for a need that has not arrived yet. The skill is powerful in nature. A crow may have to wait for a safe moment, carry something useful, or delay action while rivals are watching. The mind behind that choice is not living only in the now. It is reaching forward. Crows can trade short-term temptation for a better reward. Self-control is difficult even for humans, which is why crow patience can feel so surprising. In delayed reward tests, a bird may be shown a small treat it can take now, while a larger or preferred reward becomes available after a wait. Some crows can hold back when the better option is worth it. They are not endlessly patient, and their choices depend on timing and reward quality, but the ability is still revealing. It means the crow can compare outcomes across time. The small reward is present, visible, and easy. The better one exists only as expectation. To wait, the bird must suppress an immediate impulse and trust the pattern it has learned. In the wild, that restraint could help with avoiding traps, waiting for competitors to leave, or choosing the safest moment to feed. Sometimes intelligence is not action. Sometimes it is the decision not to move. Some crows pass danger knowledge across generations. A threat does not have to be experienced personally to become meaningful. Young crows can learn from the alarm of older birds, and that knowledge may persist after the original event has passed. If adults react fiercely to a certain person, place, or predator, juveniles can copy the response and carry it into their own lives. Over time, this creates something like inherited caution, not through genes alone, but through social experience. The young bird learns what the family already knows. This is one reason crow communities can seem to hold grudges that outlast a single season. From the bird's point of view, it is practical education. Danger is expensive to learn through trial and error. It is far safer to learn by watching panic in others. A warning can cross from parent to offspring, like a story with wings, preserving survival knowledge after the first witness is gone. Crows can remember masks linked to frightening experiences. In research on wild crows, masks have been used to separate human identity from the rest of the body. The method is simple and brilliant. One mask is worn during a stressful encounter, while another appears without causing trouble. The birds respond to the dangerous face later, even when the wearer changes. This shows that crows can connect a visual pattern with a specific emotional memory. They are not merely afraid of all people afterward. They focus their reaction on the face associated with the event. That precision matters in a crowded human world. A city bird cannot afford to panic every time someone walks past. It needs to remember which appearances have predicted risk. A rubber mask, to us, is a costume. To the crow, it can become a permanent warning sign. The face is stored, recognized, and brought back into action when it returns. People near one university were scolded by crows for years. At the University of Washington, crow researchers created one of the most memorable examples of long-term bird memory. After certain masked people trapped and handled crows for research, the birds began scolding anyone wearing that same mask. The reaction did not vanish quickly. It continued year after year, and more birds joined the response over time. Some of those birds had never been captured themselves. They appeared to learn from the alarm of others. For students and passers-by, the scene must have been strange. A person could walk calmly across campus and be loudly accused by birds because of a face covering tied to an old event. The story became famous because it turned an ordinary academic setting into proof of a hidden social archive. The crows remembered, taught, and updated their community's response. The campus was not just a place. It was part of their living history. Crows can tell the difference between individual dogs. To a crow, not every dog is the same threat. One may chase birds across a park. Another may ignore them completely. A third may move only when pulled by a person. Crows are capable of learning these differences and adjusting their distance accordingly. This is practical intelligence in a mixed urban world. If every dog triggered the same panic, the bird would waste time and energy. If no dog was taken seriously, danger could arrive too late. By watching behavior over repeated encounters, a crow can sort animals into useful categories. It may remain calm near an old, slow dog, but lift off instantly when a familiar chaser appears. This kind of discrimination shows how carefully crows read their surroundings. Their lives are filled with individual characters, not vague types. A park is not simply a park. It is a place populated by known risks with different habits. Crows sometimes follow garbage collection schedules in cities. Human routines create regular feeding opportunities, and crows can learn them with striking accuracy. In some neighborhoods, garbage appears on the curb at predictable times. Bags tear, bins overflow, and edible scraps become available before collection removes them. Crows that pay attention can arrive during the brief window when the reward is easiest to reach. This does not mean they understand calendars the way we do. It means they recognize repeating patterns in time and place. A particular street, a certain morning, the sound of bins, and the presence of trucks can all become clues. The city becomes a clock made of human habits. For wildlife, this is a major advantage of urban living. Food may not be natural, but it is often predictable. A crow that learns the schedule can feed more efficiently than one that wanders at random. In the modern world, memory can turn rubbish day into opportunity. Crows thrive near humans because human life creates opportunities. People change landscapes in disruptive ways, but adaptable animals can sometimes turn those changes into resources. Crows benefit from open lawns, road edges, crop fields, landfills, picnic areas, rooftops, and buildings that provide nest sites or lookout points. Human activity also creates leftovers, disturbed soil, insects exposed by mowing, and carcasses along roads. The crow's advantage lies in flexibility. It can shift from natural foods to human-made ones without needing a single perfect habitat. It can nest in a tree by a parking lot, feed near a schoolyard, and retreat to a safer roost by evening. This closeness can make crows seem ordinary, but it is actually a sign of remarkable adjustment. Many species decline when humans arrive. Crows often learn the new rules and make use of them. They are not simply surviving beside us. In many places, they are reading our behavior and building a life around it. Crows are omnivores with an unusually flexible diet. A specialist animal may be brilliant at one kind of feeding, but it suffers when that food disappears. Crows take another path. They can eat plant matter, animal matter, fresh food, scraps, and seasonal surprises. This wide diet lets them move between habitats and respond quickly to change. A spring field may offer insects and larvae. A shoreline may offer shellfish or stranded remains. A town may offer discarded bread, fruit, or leftovers. A forest edge may provide eggs, berries, and small animals. The crow's body and behavior are both built for this variety. Its beak can tear, probe, carry, and crack. Its memory can store where different foods appear. Its caution helps it test unfamiliar items. This feeding flexibility is one of the quiet engines behind crow success. When the world changes, a narrow eater may struggle. A crow simply begins asking a new question. What here can be eaten? A crow may eat insects, fruit, eggs, grains, or carrion. The menu of a crow reads like a map of whatever the landscape provides. It may search grass for beetles, pull worms from wet soil, raid fallen fruit, take eggs from an unattended nest, pick through spilled grain, or feed from an animal carcass. Each food type demands different behavior. Insects require searching and quick strikes. Fruit requires recognizing ripeness. Eggs demand stealth and timing. Grain rewards flock movement across open ground. Carrion calls for caution because carcasses can attract larger scavengers. This varied feeding style shows how a crow's intelligence connects to ecology. It does not rely on a single feeding technique repeated everywhere. It must decide, moment by moment, what the environment is offering and what risks come with it. That makes a crow less like a simple scavenger and more like a generalist investigator. Every patch of ground, branch, and roadside can hold a different kind of possibility. Crows help ecosystems by cleaning carcasses and recycling nutrients. Scavenging is often treated as unpleasant, but it performs an essential ecological service. When crows feed on dead animals, they help break down matter that would otherwise remain longer in the environment. Their feeding moves nutrients back into the living system, supporting insects, microbes, soil, and plants through a larger chain of decomposition. This work also helps reduce some sources of waste in human-altered places. Along roads, fields, and shorelines, crows may be among the first birds to notice a carcass and begin the cleanup. They are not acting out of charity, of course. They are feeding themselves. But nature often works this way. One creature's meal becomes part of the health of the wider landscape. The crow's dark reputation hides a useful role. It stands at the border between life and decay, converting loss into energy. In that sense, scavenging is not grim. It is one way the world keeps moving. Crows can also harm rare birds by raiding nests. Crow intelligence and adaptability can create problems for other wildlife, especially in places where human changes have boosted crow numbers. When crows raid nests, they may take eggs or chicks from smaller birds. In a balanced ecosystem, predation is normal. But when roads, buildings, landfills, and food waste allow crow populations to grow unusually high, pressure on vulnerable species can increase. This is especially concerning for rare shorebirds or island birds that already face habitat loss and disturbance. The story is not as simple as calling crows villains. They are doing what successful omnivores do. The deeper issue is that human landscapes can tilt the rules. By feeding crows indirectly and fragmenting habitats, people may give one adaptable species an advantage over others. This makes crows a reminder that intelligence has ecological consequences. A clever survivor can become a difficult neighbor when the environment around it has been reshaped. Their ecological role changes depending on habitat and human activity. A crow in a wild forest, a crow in a farming district, and a crow in a city may all belong to the same broad kind of bird, but their impact can differ greatly. In one place, it may disperse seeds, clean carrion, and help control insects. In another, it may raid crops, disturb nesting birds, or rely heavily on human waste. The bird's role is shaped by what people have changed around it. A landfill can support large numbers. A fragmented habitat can expose nests. A protected forest can offer a more balanced web of interactions. This makes crows difficult to label as simply helpful or harmful. They are responsive animals in responsive systems. Change the system, and their behavior changes too. To understand them, we have to look beyond the bird and ask what kind of world we have built around it. Crows often reveal the consequences of our own designs. Crows flourish where forests, fields, and neighborhoods meet. Edges are rich places. Where one habitat meets another, food and shelter often overlap. Crows are especially good at using these boundary zones. A wooded patch can provide nesting sites and cover. A field can expose insects, seeds, and small animals. A neighborhood can supply scraps, open lawns, and tall structures for watching. The crow moves between them all, taking what each offers. This edge-loving life helps explain why crows are so common in suburbs and mixed rural landscapes. They do not need untouched wilderness, and they do not need a fully urban setting. They do well in the in-between. These places also allow them to monitor many kinds of activity at once. A crow perched on a tree near a road and field has several worlds within view. It can see traffic, people, pets, predators, and food opportunities. The borderland becomes a command post for a bird built to notice change. Some island crows evolved unusual beaks for local foods. Islands often push evolution in surprising directions. When a bird population becomes isolated, it may adapt to foods and habitats found nowhere else. Some island crows have developed beak shapes that suit their local way of feeding. A stronger bill may help open tough items. A more slender one may help probe crevices. Over many generations, small advantages can become visible in the body itself. This matters because a beak is not merely a feeding part. It is a toolkit shaped by ancestry and environment. On islands, where competitors and predators may differ from mainland life, unusual opportunities can appear. A crow may find itself using resources that its relatives elsewhere ignore. Natural selection then begins to sculpt the bird toward that niche. The result is a living record of place. Look closely at the beak, and you can begin to read the island's menu, written into bone and keratin. New Caledonian crows search tree holes with handmade probes. In New Caledonian forests, hidden food often lies inside wood. Grubs and insects shelter in tunnels where a beak cannot easily reach. The crow's solution is to use a probe, often shaped from plant material, to fish prey from these narrow spaces. The action requires more than poking at random. The bird must locate promising holes, insert the tool carefully, feel or detect movement, and pull at the right moment. The forest becomes a puzzle box made of bark and shadow. What is extraordinary is how natural the behavior looks once you see it. The bird is not performing for a laboratory reward. It is making a living with equipment it prepares from the vegetation around it. In this environment, tool use is not a rare stunt. It is part of everyday foraging. A branch, a leaf stem, or a twig can become the difference between hunger and success. A young tool-making crow needs practice before becoming skilled. Tool use may look smooth in an experienced adult, but young New Caledonian crows are not born as masters. They must handle materials, watch others, make mistakes, and gradually refine their technique. A juvenile may choose a poor stem, hold it awkwardly, probe the wrong place, or lose interest before success. Over time, movements become more efficient. The bird learns which materials are worth selecting and how to guide a tool into hidden spaces. This learning period matters because it shows that crow skill is not only instinct, it develops through practice in a social and physical environment. A young crow is surrounded by examples, but it still has to build control through its own body. The process resembles apprenticeship more than automated behavior. The finished skill is impressive because it carries a history of failed attempts. Behind a precise tool movement lies a long education of beak, foot, eye, and patience. Tool use in crows can spread through family learning. In tool-using crow species, techniques can pass from one generation to the next through close observation. A young bird watches parents or other experienced family members choose materials, shape them, and probe for food. It may not copy perfectly at first, but repeated exposure guides its attention toward the right objects and actions. This creates a form of animal culture. The behavior persists not simply because genes build it fully formed, but because families provide a learning environment. Different groups may favor different tool materials or methods depending on what grows nearby and what older birds demonstrate. That makes the forest a place of traditions, not in the human ceremonial sense, but in the practical sense of know-how passed on by living example. When a young crow learns how to work a twig into a crevice, it is receiving more than a feeding trick. It is inheriting a local solution discovered before it hatched. Crows can judge whether a tool is too short. A tool is only useful if it fits the job. In experiments, crows presented with different lengths of sticks can often select the one that reaches the reward. This sounds simple until you picture the task from the bird's point of view. It has to compare the distance to the food with the object available, then choose before using it. A stick that is too short may look promising but fail at the final moment. A successful bird avoids wasting effort by judging the relationship in advance. In the wild, that skill would save time and reduce exposure to rivals or predators. A crow probing bark or a hole cannot afford endless errors. The right length matters. The ability also suggests that crows attend to the geometry of a problem, not merely the presence of a tool. They are evaluating fit, reach, and go as parts of one practical calculation. Some crows strip leaves from twigs before using them. A raw twig is not always ready for work. Leaves and side branches can catch, bend, or block entry into a narrow hole. Some tool-using crows modify plant material by removing unwanted parts before probing. This preparation is important because it shows an understanding of performance. The bird changes the shape of the object so it can move more smoothly through a small space. It is not making something beautiful. It is making something functional. The behavior can look almost like craftsmanship, although it grows from practical need rather than human intention. A crow grips the twig, bites away the extra pieces, tests the result, and uses it to reach food hidden beyond the beak. The whole sequence reveals careful attention to material. In a forest full of branches, the useful tool is not always found. Sometimes it has to be improved, one small adjustment at a time. Crows may save their best tools after a successful hunt. For a tool-using crow, a well-made probe can be valuable. If it has just worked, dropping it and starting again may be wasteful. Some birds appear to keep or store effective tools after use, carrying them to the next foraging site or placing them somewhere nearby. This behavior makes sense when good materials are not equally available everywhere. A tool that is the right length, shape, and stiffness can save time on the next attempt. It also suggests that the bird treats the object as more than disposable debris. The tool has a history of success. It may be worth retaining because it can work again. That idea brings a new depth to the image of a crow with a twig in its beak. It may not be carrying a random forest scrap. It may be holding onto a proven instrument, one that has already helped unlock a hidden meal. A crow's intelligence evolved without primate hands or speech. Human beings often imagine intelligence through human abilities. We build, speak, point, grasp, and explain. Crows remind us that cleverness does not require the same equipment. They have wings instead of hands, beaks instead of fingers, and calls rather than spoken language. Yet they can remember individuals, solve physical problems, plan for later needs, and learn socially. This is remarkable because it means evolution can reach complex cognition through a very different body plan. A crow cannot take apart the world with hands the way an ape can. It must use beak, feet, posture, timing, and attention. Its mind is shaped by flight, caching, predators, social life, and changing food sources. The result is intelligence adapted to a bird's reality, not a lesser version of our own. Crows show that nature does not copy one blueprint. It builds many kinds of minds, each suited to a different way of being alive. Bird brains pack many neurons into a small space. For a long time, people assumed that small brains meant simple minds. Birds helped overturn that idea. Their brains are organized differently from mammal brains, and many species pack large numbers of neurons into compact regions. This means a crow can have impressive processing power inside a skull that looks tiny by mammalian standards. The efficiency matters. Flight favors lightweight bodies, so birds cannot simply grow heavy heads without cost. Evolution found another solution. It built dense neural machinery that supports complex behavior without the same bulk. This helps explain why crows can perform tasks that once seemed reserved for animals with larger brains. Size alone is not the whole story. Organization, density, and connectivity matter deeply. A crow perched on a branch may carry a brain no bigger than a walnut, yet inside it is a busy network capable of memory, judgment, learning, and flexible response. Crows challenge old ideas about what intelligence should look like. There was a time when animal intelligence was often ranked by how closely it resembled our own. Crows make that ranking feel too narrow. They do not build cities, speak in sentences, or shape metal with hands. Yet they excel at problems that matter in their world. They remember social information, track hidden food, exploit new environments, and respond to other minds around them. Their intelligence is practical, embodied, and ecological. It grows from the demands of a life spent moving between danger and opportunity. This forces a better question. Not which animal is most like us, but what kind of thinking does each life require? A crow's mind is not a human mind trapped in feathers. It is its own solution, refined by millions of years of survival. Once we understand that, intelligence begins to look less like a ladder and more like a branching forest of possibilities. Crows can make decisions based on uncertain evidence. In some experiments, crows are asked to respond to signals that are not perfectly clear. A cue may suggest one reward or another, but the bird has to judge what is most likely rather than what is guaranteed. Their responses show that they can act on degrees of uncertainty. This matters because life rarely presents complete information. A rustle in grass may be food or danger. A distant call may come from a relative or a rival. A person approaching may be harmless or risky. Crows must constantly make decisions before every fact is known. The ability to weigh uncertain evidence helps them avoid both recklessness and paralysis. It is a subtle kind of intelligence, less dramatic than bending wire or cracking nuts, but perhaps more important in daily life. The crow survives by reading incomplete clues and choosing a response before the world has fully explained itself. Some crows show signs of understanding cause and effect. A cause is the hidden link between action and result. Crows have shown, in different ways, that they can learn more than simple associations. They may recognize that dropping a heavy object into water raises a level, that pulling one string brings food closer while another does nothing, or that moving a barrier changes access to a reward. These tasks suggest attention to how events connect. The bird is not merely memorizing a picture. It is learning something about what makes the outcome happen. That ability is vital in the wild. A crow must know which actions open food, which disturb prey, which provoke rivals, and which dangers follow certain movements. Cause and effect turn the world from a blur of happenings into a system that can be tested. Every successful crow is, in a modest but real sense, an experimentalist. It acts, watches the result, and adjusts its next move. Crows can adjust their behavior when a puzzle changes. A rigid animal may learn one solution and fail when the situation shifts. Crows can be more flexible. If a familiar task is altered, the reward moves, the tool changes, or an old route stops working. Some birds explore alternatives rather than repeating failure endlessly. That flexibility is one of the most important marks of intelligence. It means the crow is not only trained by habit, it can update its behavior when the evidence changes. In nature, this is essential. A food source may vanish, a rival may appear, a hiding place may be discovered, or a safe path may become dangerous. The crow that adapts has an advantage over one that insists on yesterday's answer. This kind of mental agility is easy to overlook because it may unfold in small movements. A pause, a glance, a new angle, a different attempt. Then, suddenly, the puzzle opens. A crow may inspect a problem before acting. Before a crow commits to a difficult task, it may spend time looking, shifting position, and studying the setup from different angles. That pause is easy to miss, but it can be the most important part of the behavior. Instead of rushing straight in, the bird gathers information. Where is the food? What blocks access? Which part moves? Is another animal watching? This inspection can make later action look sudden, as if the solution appeared all at once. In reality, the work began during stillness. In the wild, this habit is valuable because mistakes can cost energy or attract danger. A crow approaching a strange object, a new feeder, or a difficult shell may circle first, test lightly, then step back. It treats the world as something to be read before it is touched. That thoughtful hesitation is one reason crows often seem less like machines of instinct and more like investigators. Crows can learn from failure without giving up quickly. A failed attempt does not always end the story for a crow. If a container will not open, a shell will not crack, or a hidden morsel stays out of reach, the bird may change its method and try again. It may pull from another side, strike harder, choose a different perch, or wait for the object to shift. This persistence is not blind repetition. The important part is variation. Each failure becomes information about what does not work, narrowing the path toward what might. In natural settings, this can make the difference between hunger and discovery. Many foods are protected by husks, shells, bark, lids, or awkward locations. A bird that quips at the first obstacle loses access to all of them. A crow's stubbornness is therefore a kind of intelligence in motion. It does not simply endure frustration. It turns frustration into a teacher, one attempt at a time. Crows sometimes deceive rivals by hiding food in false places. When another bird is watching, a crow may create a performance around secrecy. It can approach a patch of ground, poke as though burying food, then move away with the real item still in its beak. The watcher may investigate the false spot, while the owner hides the food somewhere else. This behavior is fascinating because it depends on attention. The crow is not only concerned with where the food goes, it is concerned with what the rival believes happened. That does not prove the bird has human-like thoughts, but it does show a sophisticated response to social pressure. In a world of thieves, appearances matter. A false cache buys time, misdirects competition, and protects a future meal. The drama may unfold silently on a lawn or beneath a tree, but it has all the tension of a heist. One bird hides treasure, while another tries to read the trick. Other crows can counter deception by waiting and watching. A crow that steals caches cannot simply trust the first hiding place it sees. Experienced watchers may remain patient, tracking the food owner instead of rushing to the obvious spot. If the first cache is false, the thief gains nothing by acting too soon. Waiting allows it to see whether the owner moves again, looks nervous, or returns to relocate the prize. This creates an arms race of attention. One bird tries to conceal information. Another tries to detect the concealment. Neither side needs language for the contest to become complex. Timing, posture, and movement become clues. In some cases, the best move is not to move at all. A watcher that seems uninterested may be gathering exactly the information it needs. This makes crow society feel almost like a field of quiet calculations. Food may be buried in the ground, but the real struggle happens in the minds above it. Crow intelligence is shaped by rivalry as well as cooperation. Crows live in a world where others can help them, threaten them, or steal from them. That social pressure may be one reason their minds became so flexible. Cooperation rewards memory and trust. Rivalry rewards caution and strategy. A crow must know which companion is useful, which neighbor is aggressive, and which watching bird might rob a cache. These demands create daily mental challenges. The bird is not solving abstract puzzles for entertainment. It is navigating relationships where the same individual may be ally in one situation and competitor in another. Such a world favors brains that can update, remember, and judge context. The result is a social intelligence full of tension. Crows gather in groups, share warnings, and raise young together, yet they also deceive, compete, and steal. Their brilliance may come partly from living at this edge, where community and conflict are always close together. Crows pair up in long-lasting bonds. A crow pair is often more than a brief breeding arrangement. Many species form partnerships that can last for years, sometimes for life if both birds survive. The bond is practical as well as social. Two experienced adults can defend a territory, choose nest sites, share feeding duties, and respond quickly when threats appear. Familiarity matters. A long-term partner becomes predictable in a dangerous world. Each bird learns the other's calls, habits, and reactions. During breeding season, that coordination can be crucial because eggs and chicks require constant protection. Outside that season, the pair may still move through the landscape together, maintaining a shared claim on place. This kind of bond gives crow life a hidden continuity. The birds seen calling from the same trees year after year may not be strangers passing through. They may be a pair with a long private history, written in repeated flights and shared vigilance. Mated crows may defend a territory together for years. A good territory is worth guarding. It may contain safe nesting trees, reliable food, clear lookout points, and escape routes from predators. Once a crow pair secures such a place, they may defend it season after season. Their defense is not constant battle. Much of it is presence, calling, chasing intruders, and making boundaries known. Over time, the pair becomes deeply familiar with the local terrain. They know where danger often appears and where food is likely to emerge after rain, mowing, harvest, or human activity. Defending a territory together also strengthens coordination. One bird may spot a threat while the other responds. One may stay near the nest while the other forages. The place becomes part of the pair's partnership. To us, a nesting area may look like an ordinary patch of trees. To crows, it may be a hard-won home range, protected through memory, effort, and time. Crow parents feed chicks many times each hour. Inside a crow nest, the pace of life is relentless. Newly hatched chicks are helpless, with open mouths, weak bodies, and a constant need for warmth and food. The adults must search, return, deliver small portions, and leave again. During the busiest periods, feedings can happen again and again within a single hour. Every trip carries risk. A parent must find suitable food, avoid predators, and keep watch for rival birds. the chicks grow quickly and their demands rise with them. Insects, soft animal matter, and other protein-rich foods become especially important because young bodies are building feathers, muscle, and bone at speed. From the ground, we may only hear rough begging calls from the treetops. Above us, a complex cycle is underway. Parenthood for crows is not casual. It is a sustained labor of searching, guarding, feeding, and returning, repeated until the nest becomes a launching place. Young crows beg loudly long after leaving the nest. A fledgling crow may look nearly grown, but it is still learning how to live. After leaving the nest, young birds often follow adults and beg with loud, persistent calls. The sound can be comical, demanding, and impossible to ignore. It signals that the young crow still depends on family support while developing the skills needed for independence. Finding food is not simple when meals must be recognized, handled, opened, or stolen at the right moment. Flying well also takes practice, especially when branches, roads, pets, and weather complicate the world. Begging keeps the adults engaged during this vulnerable transition. It also reveals the long learning curve behind crow survival. A young crow is not instantly competent because it has wings. It must become competent through guidance, practice, and repeated failure. Those loud calls are the sound of apprenticeship, broadcast from a bird standing between childhood and the full demands of the sky. Crows recognize relatives within their extended social networks. Crow society can extend beyond a simple pair and their current chicks. In some groups, individuals maintain relationships with parents, siblings, offspring from previous years, and familiar neighbors. Recognizing relatives matters because kin can influence cooperation, tolerance, and conflict. A bird may allow a family member closer to food, accept help near a nest, or respond differently to a relative's alarm. This requires memory for individuals over long periods. Plumage may look similar to us, but crows use a combination of voice, behavior, location, and repeated experience to know who is who. Such recognition helps explain why their gatherings are not just anonymous flocks. Beneath the dark feathers are social histories. Some birds grew up together. Some share parents. Some have defended the same territory. When crows call across a neighborhood, they may be addressing a network filled with old bonds and remembered roles that humans barely perceive. Some crows accept unrelated helpers during the breeding season. Although family help is common in some crow systems, cooperation does not always require close kin. Under certain circumstances, an unrelated bird may remain near a breeding pair and assist around the territory or nest. This arrangement may benefit the helper if breeding opportunities are scarce, if the territory offers safety, or if staying nearby provides experience. For the breeding pair, an extra bird can mean more eyes watching for threats and more support during demanding weeks. The relationship is not charity. It works when the balance of costs and benefits makes sense for everyone involved. This makes crow breeding systems more flexible than a simple family tree. Social life can be shaped by local conditions, territory quality, population density, and individual history. A bird without a nest of its own may still have a role in raising the next generation. In crow society, belonging can sometimes be earned by usefulness. Crows may attack mirrors because they mistake reflections for rivals. The mirror can create a strange problem for a crow. The reflection moves exactly when the bird moves, stares back from the same distance, and appears to occupy valuable space. Many birds react aggressively to mirrors because they interpret the image as another individual intruding on their territory. Crows may peck, display, call, or strike at the glass, especially during breeding season when defense is heightened. This does not mean they are unintelligent. Mirror self-recognition is a specialized ability, and even clever animals may not interpret reflections the way humans do. The interesting part is how the reflection hijacks normal social rules. A rival that never retreats, never yields, and copies every movement becomes intensely frustrating. The crow is responding to what looks like a persistent challenger. In a window, car mirror, or shiny surface, the bird meets a perfect illusion, and its territorial instincts answer before deeper interpretation can catch up. Crows sunbathe with open wings for comfort and feather care. On warm days, a crow may spread its wings, fan its tail, and sit with its body flattened toward the light. The posture can look alarming if you have never seen it before, as though the bird is injured or frozen. In many cases, it is simply sunning. Sunlight may help warm the body, dry damp feathers, and make parasites more active so they can be removed during preening. The heat can also improve feather maintenance by changing conditions on the skin and plumage. For a bird, feathers are essential equipment. They support flight, insulation, display, and protection from weather. Caring for them is not vanity. It is survival. Sunning gives the crow a way to use the environment as part of its grooming routine. The image of a black bird spread wide in sunlight is not a sign of laziness. It is maintenance, comfort, and biology meeting in one still posture. Crows use ants on their feathers in a behavior called anting. Anting is one of the stranger behaviors seen in birds. A crow may stand on an anthill, allow ants to crawl through its feathers, or even pick up ants and rub them into its plumage. The ants often release defensive chemicals such as formic acid. Researchers have proposed several explanations. The chemicals may help deter parasites. They may soothe irritated skin. They may make ants less noxious before being eaten. The exact purpose can vary, and the mystery is part of the fascination. What is clear is that the bird is interacting with another species in a deliberate and unusual way. It is not simply feeding or fleeing. It is using living insects as part of feather care or sensory experience. The sight can seem bizarre, almost ritualistic, but it belongs to the practical world of plumage maintenance. A crow's relationship with ants may be more complicated than predator and prey. Anting may help birds manage parasites or feather condition. Feathers are vulnerable structures. Tiny mites, lice, and other irritants can live among them, affecting comfort and condition. Because flight depends on well-kept plumage, birds invest time in preening, bathing, dusting, sunning, and sometimes anting. The chemicals released by ants may discourage parasites or influence the feather environment in ways that benefit the bird. Scientists remain cautious because the behavior may have more than one function, and not every case is easy to interpret. Still, the possibility is remarkable. A crow may exploit the defensive chemistry of insects to maintain its own body. This is a subtle form of environmental use, very different from sticks or stones, but no less interesting. It shows that the crow's world is full of resources beyond obvious food. A patch of ants can become part of self-care. Nature often hides its cleverest solutions in relationships that look strange until we understand the pressures behind them. Crows molt worn feathers and renew their flight surfaces. A feather is strong, but it is not permanent. Sunlight, friction, rain, dirt, and flight gradually wear it down. Crows replace old feathers through molting, a carefully timed process that renews their wings and body covering without leaving them unable to survive. Flight feathers are especially important because they must support lift, steering, and braking. Losing too many at once would be dangerous, so replacement happens in a controlled sequence. During molt, a crow may look slightly ragged or uneven, but beneath that temporary disorder is a precise biological renewal. New feathers grow from follicles, supplied by blood while developing, then harden into the sleek surfaces needed for flight. This process demands energy and often coincides with seasonal cycles. It is a reminder that a crow's body is constantly maintained. The bird that glides over a street or field is flying on equipment that has to be replaced, repaired, and protected across its lifetime. Crows are not truly black when sunlight reveals their feathers. From a distance, a crow may appear like a simple black shape against the sky. Up close, especially in bright light, the feathers reveal far more complexity. Their darkness can shift with glossy reflections, showing subtle tones that depend on angle and condition. This effect comes from feather structure as well as pigment. Microscopic surfaces influence how light reflects, creating a sheen that can seem metallic. The result is not the flat black of ink, but a layered darkness that changes as the bird moves. This matters because plumage is not only camouflage or covering. It can signal health, age, and condition to other birds. A sleek, reflective coat may indicate good maintenance and strong feathers. To human eyes, the beauty is easy to overlook because crows are so common. But familiarity can hide wonder. The next time sunlight touches a crow's back, the plain black bird may briefly become a prism of shadow. Their feathers can shimmer with blue, purple, or green tones. The iridescence in crow feathers is one of their quiet marvels. A bird standing in shade may seem entirely dark, but as it turns, a surface can flash with blue, violet, or green. These colors are not painted on like ordinary pigment. They arise partly from the way feather microstructure bends and reflects light. The same feather can look different from different angles, which is why the shimmer appears and vanishes so quickly. For crows, this sheen may play a role in visual communication, especially at close range. It can also reveal feather quality, since damaged or dirty plumage may reflect less cleanly. The effect gives crows an elegance that many people miss. Their beauty is not bright like a parrot's or delicate like a songbird's. It is hidden in the border between darkness and color, waiting for the right angle of light to reveal what was there all along. Ancient cultures often linked crows with prophecy and transformation. Crows have followed human imagination for thousands of years because they appear at moments people find meaningful. They gather near battlefields, farms, settlements, roads, and places of death. They are dark, vocal, watchful, and difficult to ignore. Ancient observers saw birds that seemed to know things before people did, arriving where change or danger was unfolding. From that perception grew associations with omens, messages, prophecy, and the crossing between life and death. These beliefs were not scientific explanations, but they were not random either. They emerged from real crow behavior, filtered through human fear and wonder. A bird that remembers faces, gathers around the dead, and calls from high places almost invites interpretation. Across cultures, crows became symbols of thresholds. They marked the point where the ordinary world seemed to open into something uncertain. Their intelligence gave the old stories weight, even when the meanings were shaped by myth. Crows appear in stories because people noticed their strange awareness. Long before laboratories measured crow cognition, people were already watching them. Folktales often portray crows and their relatives as tricksters, messengers, problem solvers, or thieves. These roles make sense because the birds behave in ways that catch attention. They steal boldly, recognize danger, investigate objects, gather in groups, and seem to look back at us with intention. Storytellers turn those observations into characters. A crow in a tale might outwit a larger animal, carry news, or cross between worlds. The details vary from culture to culture, but the underlying impression is similar. people sensed that these birds were not ordinary background creatures. They were watchers with appetites, memories, and schemes. Modern science has not erased that feeling. It has given it structure. The old stories were not formal studies, yet they preserved a human response to something real. Crows have always seemed aware because, in many practical ways, they are. Norse myth gave Odin 2 raven messengers, not ordinary crows. In Norse mythology, the god Odin is accompanied by 2 ravens named Hugin and Munin. Their names are often translated as thought and memory, which is striking given what modern science has revealed about corvid minds. Each day, the ravens fly across the world and return with knowledge. They are not merely decorative birds. They are extensions of perception, carrying news from distant places to a god associated with wisdom, war, poetry, and fate. Although ravens are not the same as crows, they belong to the same intelligent family, and the myth reflects a deep human recognition of corvid watchfulness. To imagine thought and memory as black birds crossing the sky feels less accidental when we know how observant these animals are. The story turns a biological truth into sacred image. Corvids notice, remember, and report through behavior. Myth gave that power wings large enough to circle the world. Many cultures see corvids as tricksters rather than simple omens. The trickster role fits crows and their relatives because they are clever, opportunistic, and difficult to control. In many traditions, corvid figures steal light, reshape the world, break rules, or expose human foolishness. They are not always good or evil. They are disruptive agents of change. This complexity matches the birds themselves better than a simple symbol of bad luck. A crow can raid a nest, clean a carcass, warn its family, solve a puzzle, and play with an object that seems useless. It does not fit neatly into one moral category. Trickster stories capture that slippery quality. They present intelligence as something creative and dangerous at the same time. A trickster survives by noticing loopholes. So does a crow. When cultures cast these birds as rule breakers, they may be responding to a real pattern in nature. Corvids often find the weakness in a system, then use it. The Tower of London keeps ravens as famous symbolic guardians. At the Tower of London, ravens have become part of one of Britain's most famous living legends. Tradition says that if the ravens leave, the kingdom will fall. The story is not ancient in the way many people imagine, but it has become powerful through repetition, ceremony, and the drama of the place itself. The birds are cared for by a dedicated raven master, and visitors often treat them as more than animals. They are symbols walking on black feet through a fortress filled with royal history, imprisonment, execution, and spectacle. Although ravens are larger than crows, their presence reinforces the broader human fascination with corvids as watchers and guardians. The legend works because the birds look as if they belong among secrets. They are intelligent, bold, and theatrical without trying to be. In that setting, a raven is not just a bird. It becomes part of the architecture of memory. Folklore often exaggerates crows, but their intelligence is real. Stories have given crows many supernatural powers. They have been treated as omens, messengers, shapeshifters, and keepers of hidden knowledge. Science does not support the magical claims, but it does reveal why such stories were easy to believe. Crows really do remember individuals. They really do gather around danger. They really do learn from one another, solve problems, and act with striking flexibility. The mythic crow is exaggerated, yet it is built on observable behavior. This is what makes the boundary between folklore and biology so interesting. People did not invent crow mystery from nothing. They noticed an animal that seemed to understand more than expected, then explained that feeling through the language of their time. Today, we can replace superstition with evidence without losing wonder. The crow does not need to be supernatural to be astonishing. Its real abilities are already strange enough to make the old stories feel understandable. Crows suffered heavily from West Nile virus in North America. When West Nile virus spread across North America, crows were among the birds hit especially hard. Many died quickly after infection, and their bodies became early warning signs for public health officials tracking the disease. In some areas, local crow populations dropped sharply. The event revealed a vulnerable side of a bird often seen as tough and adaptable. Intelligence cannot protect against every microscopic threat. A virus moves through blood, mosquitoes, and ecological networks without caring how clever its host may be. For researchers, the loss of crows provided important information about disease spread. For neighborhoods, it sometimes changed the soundscape. Places once filled with familiar calls became noticeably emptier. The outbreak showed how connected wildlife health and human health can be. A dead crow on the sidewalk was not just a sad sight. It could be a signal that a larger invisible process was moving through the environment. Crow declines helped scientists track the spread of disease. Because crows were highly susceptible to West Nile virus, their deaths became useful indicators during the early spread of the disease in North America. Reports of dead birds helped officials map where the virus was appearing and how quickly it was moving. This was grim information, but valuable. Wildlife can reveal patterns that human cases alone may miss, especially when an infection circulates through mosquitoes and birds before people notice it. Crows, because they are visible, widespread, and often live near humans, became part of a surveillance system, almost by accident. Their decline turned into data. This reminds us that animals are not separate from our public health story. They share air, water, insects, neighborhoods, and changing climates with us. When disease moves through them, it can warn us about conditions we have not yet seen clearly. The crow became, unwillingly, a messenger from the hidden world of infection. Crows can act as sentinels for environmental change. A sentinel species is one that reveals something about the health or transformation of an environment. Crows can play that role because they live close to people, respond quickly to changing food sources, and are visible enough for patterns to be noticed. Rising numbers may indicate abundant human waste or altered habitats. Sudden declines may point to disease, poisoning, or other pressures. Shifts in nesting sites, roost locations, or feeding behavior can reflect changes in land use and climate. Crows are not perfect indicators, but their adaptability makes them informative. They often stand at the meeting point between wild systems and human systems. Watching them can show how our choices ripple outward. A crow population is not just a collection of birds. It is a moving response to roads, farms, cities, disease, weather, and food. In that sense, crows help translate environmental change into behavior we can actually see. Studying crows helps reveal how intelligence evolves in nature. Crows are valuable to science because their intelligence developed independently from the intelligence of primates. That gives researchers a natural comparison. If very different animals evolve similar abilities, such as planning, tool use, social learning, or memory for individuals, then those abilities may arise under similar pressures. Crows face challenges involving food storage, competition, danger, and complex social life. Primates face different bodies and habitats, yet some mental demands overlap. By studying crows, scientists can ask which problems encourage flexible thinking and which brain designs can support it. This helps move the study of intelligence away from human-centered assumptions. A crow does not need hands or speech to become cognitively impressive. It needs a world where remembering, adapting, and judging others improves survival. Every experiment with crows therefore points beyond the bird itself. It helps answer a larger question. How many paths can evolution take toward a clever mind? The hidden world of crows is closer than most people realize. You do not have to travel to a remote rainforest or distant island to encounter remarkable animal intelligence. It may be on the telephone wire outside a shop, in a park beside a footpath, or on a roof across the street. Crows live near us so successfully that their wonder becomes easy to ignore. We turn them into background noise, yet they are watching routes, remembering faces, weighing risks, and responding to small changes in our shared landscape. Their hidden world overlaps with ours every day. A schoolyard can be a foraging ground. A parking lot can be a puzzle. A garden can be a defended territory. The familiar setting makes their minds more astonishing, not less. They are not exotic because they are far away. They are extraordinary because they are so close, carrying a complex life through places we think we already understand. Every neighborhood crow may be watching, learning, and remembering. The next crow you pass may know more about the local world than you imagine. It may know which bins overflow, which cats patrol the walls, which people toss crumbs, and which corners become dangerous when traffic speeds up. It may remember a face, a sound, a dog, a tree, or a place where food once appeared after rain. It may be part of a family whose history in that neighborhood stretches back years. This is why crows can change the way we see ordinary streets. They reveal that intelligence is not confined to laboratories, distant wilderness, or human life. It is perched above us, making decisions in real time. The bird glancing down from a wire is not just decoration against the sky. It is an observer with a memory, a strategy, and a stake in the same landscape. Once you notice that, the neighborhood feels inhabited in a new way. And so, we come to the end of our journey through the hidden world of crows. We have watched them recognize faces, remember danger, solve puzzles, and shape tools with a patience that feels almost impossible for a bird. We have followed them through city streets and winter roosts, across family territories, into forests where young birds learn from older ones, and into the long shadow of stories where crows have appeared as messengers, tricksters, and watchers at the edge of mystery. What began as a familiar black shape on a rooftop has become something far more astonishing. A crow is not just passing through the background of our lives. It is listening, learning, choosing, remembering, and moving through a world rich with signs we rarely notice. The streetlight, the tree branch, the passing face, the open field after rain. To a crow, each may hold meaning. And perhaps that is the loveliest thought to carry with you now. The world is fuller than it seems. Even the ordinary places around us are alive with hidden minds, private histories, and small decisions unfolding beyond our view. If you enjoyed this gentle journey, you are always welcome to like, subscribe, or leave a thought below. It helps other curious souls find their way here too. And if you happen to still be awake, there should be another video on the screen now, waiting to carry you into the next soft mystery. But for now, let the crows fade into the evening sky. Let the rooftops grow still. Let your shoulders loosen, and let your breathing settle into its own easy rhythm. There is nothing more you need to follow, nothing more you need to hold. Just rest now, while the dark birds of thought drift farther away. Sleep well, and good night.